Okay, everybody needs to have your mask covering your nose and your mouth the entire class period. I really don't want to have to say that more than once today. Got a few minutes still. You can click on attendance when you get a chance. I'm going to tell you a little something else about attendance in just a minute. I'll sign in on another device. It's going to be recorded. Yeah. All right, so while we're waiting for everybody to come in, and I'll say this again, what we have to do is we have to show where everyone is sitting every single day. So every day you guys are going to come in and you're going to come to the 5T seating chart. And you're going to click on the 5T seating chart. And let's make sure the seating. Okay. And you are going to come and you're going to type in your name. Remember, once you type in your name, you must press enter or click on a white square. Now, if you guys are on Zoom, then I want you to type your name down here at the bottom. So you get credit for being here, but we know that you are on Zoom and you're not in the class. So for those of you just coming in, please make sure that you come in every single day. I know it's pain, but we got to do what we got to do. And you have to type your name in every single day. I'm going to remind everybody, your mask must cover your mouths and your nose for the entire class period. Everybody, the whole time. Please don't take it down to talk. Please don't take it down when you're just sitting there. Please make sure that it's covered the entire time, okay? I know it's a pain for people wearing glasses, I get it, but we have to do it properly. We still got about 2 minutes before class starts. In the back in red, you need to keep your mask over your nose and your mouth, the whole class. One more minute. So even if you come in late in the future, this will still be up. You know, I'm not going to lock it. I'm not going to lock y'all out of it until class is over. So even if you come in late, you need to not only check in on iClicker, but also with this. I'm just doing what I'm told, right? We all kind of just do the best we can with what we got. I don't know how your other professors are doing this. All different ways. I wish they had told us at the beginning of the semester, this is how everyone is going to do it. I would have been on board, you know, like it'd be easy, everybody doing the same thing. But instead they were just like, figure it out. All right, so let's see, let's start with our joke for the day. What is orange and sounds like a parrot? A carrot. I really like that one. All right, it looks like people are still typing in, so I'll give y'all a second one for today while we're waiting for everybody to finish up the attendance. Let's see, how's that go? I have too many jokes. I have way too many terrible, terrible jokes. Who stole the soap from the bathroom? The robber ducky. Okay, that's enough terrible jokes. All right, so make sure that you have entered your name, and do me a favor, close it and go back to it and make sure your name is there. Make sure your name is there just in these first couple of times until we get into the rhythm, so that we make sure that it's an accurate seating chart. Okay, so close it and go back to it and make sure your name is there. All right, I'm going to go ahead and close it. And minimize that. And you should have done attendance on the iClicker. So I know how many people we have today. We're up to 40. All right, we will eventually get to chapter 2, but we're not there yet. We're going to start out with some iClicker questions. All right, so get out your clickers, get out your calculators, get out your best friends. Who's your best friend? In this class, at least, who's your best friend? Exam resources, your exam resources. These are your best friends. You will need your best friend every day for class, every homework. Your best friend should be your best friend, right? Okay. All right. And if you are unable to take your name onto this sheet, send me an email that has your name and your seat number. Okay, y'all ready? I'm gonna come down. Which one? Are we gonna do this one? Okay. Okay. Identify the number of significant figures that the syringe measurement should be reported. So when we say this, right, if you're not given a number, this is also equal to the number of places past the decimal, because you don't know how many are ones, how many are zeros, right? So it's the same thing in this case. So this is something that you actually will come into contact with, right? You're giving somebody some medication. What do you actually record as the dose that you provided to them, right? That's really important. So when you're looking at any given measurement, before I even open the question, let me give you a hint. How do we know how many significant figures to report, or how many places past the decimal to report if we're making a measurement. You're not doing a calculation, you're making a measurement. If y'all jump in and throw out some answers, I'll help you. Well, not a number, but like, how do I know? You have to look at the actual position, right? So I would normally draw up some kind of fluid in here, and I would look at the position of the fluid in terms of what? Well, that's true. That's true. You have to base it on whatever the doctor prescribed. That's true. But whether the doctor prescribed 1 mil or 10 mils, your precision is going to be different depending on what kind of a syringe you use, right? If you use a 5 mil syringe, a 10 mil syringe, a 100 mil syringe, right? What's the difference between those syringes? How many tick marks, right? How many tick marks, right? The more tick marks you have, the more precise your answer can be. Whoa, I'm going to hit myself in the face with this mask and microphone, right? The more tick marks I have, the more precise I can be. So when I'm looking at a measurement, making a measurement, what am I going to do? If I have a meter stick and I'm trying to measure distance, right? Let's say I'm trying to measure distance. If I want to know how many meters long something is, I'm going to put my meter stick up, right? I'm going to look at where that thing stopped, and I'm going to look at all the tick marks that are on that meter stick. And I'm going to give all the known, and then I'm going to estimate one more. This was from the lecture, right? So all the known, and then estimate one more. So tell me, on this, identify the number of significant figures the syringe measurement should be reported to. So all of the known and one more that you estimate. And remember, I'll let you talk to your partners after you try it on your own. Mass over the nose. Thank you. Okay, 10 seconds. There were more than 40 people. Don't leave it blank, right? There were more than 40 people. Okay, 1 minute. I'm going to close it at 1 minute. All right, so now I want you to confer with the people around you because they're really smart, right? Just like you. So talk to them. You decide again and then buzz in again. So you have 1 minute. Oh, I'm in chat. I'm sorry. Oh, it's okay. Okay, so buzz in again if you have not. Buzz in again if you have not. So I'm going to cut it off at 1 minute in the future, but you need to go in and respond. Please go in and respond. We had like 50, no, was it 43? 43. So y'all come on. All right, I'm ending it at 1:25. 1:25, I'm ending it. No, it's supposed to be at 1 minute. Okay. So what did we say? Okay, so we have kind of a variation on our answers. So when we look at this, what are these big tick marks? Each of these big tick marks. A 10th, right? So the 10th place. So let's just pretend we have a measurement. Let's just put values in, right? Okay, so I'm going to say that was 1. All right, now what are these tiny tick marks? And this medium tick mark? Hundredths, right? So let's say we had a measurement there. All right, those are all of our tick marks, right? Because from here to here, there are 10, right? 1, 2, 3, 4, and then this big one is 5, right? Yes? Okay, so if these are the known, these two are the known, how many more do I need to go? 1, which is my estimated, E-E-E-E-S-T, estimated, right? So you give all the known plus 1 more that you estimate. Maybe it's a 1, maybe it's a 0, whatever it is, right? So you should have reported to 3. Yeah? Okay, so what did we say? 3, and I got to go back and grade this one. So we definitely increased, but we were still pretty torn about that one, right? So look at what you know, those are the black tick marks, and then estimate 1 more place past.
So because there's like 10 of the tick marks, and we have like the 100th place, we estimate 1 more to the 1000th place.
Correct.
So if there wasn't the little tick mark and we just had like the longer ones,
Correct.
we would just do 2.
Correct. Because 1 would be known and the other would be estimated. That is correct. That is correct. Okay, let's see if we can apply what we just did. Y'all ready? Okay, this is what you gave a patient. What is in this syringe is what you gave the patient. Now, I know you can't really log this in. Those of you who have a handheld eye clicker, you can't actually type it in. I'm going to throw it up there for those who are using the app, but I'm not going to count this one, okay? But I really do want you to try. So this is actually a numeric.
So we should just like do this in our head.
Just write it down, like write it down. It's okay. I'm not going to count it. Just write it down. How much should you record in your medication log if you're giving the patient this? So type it in if you can on the app. And if you can't, it's okay. I'm not really going to count it. Masks need to be over noses the entire time. Okay, 10 seconds. If you can, type it in, put your guess in. I'm not going to show it to everybody. It's okay. Just guess. Okay. So you have something written down, right? Okay, turn and talk to your neighbor. I'll give you a minute. Turn and talk to your neighbor. Make sure your masks are covering your noses. Okay, got about 15 seconds. If you type in your answer, that'd be cool. If you can, type in your answer. Be nice. Just to see what we have a change in and what we don't. Okay, so tell me What should I write first? Let's go from the known values. Start with the known values first. What do we see? 0.3. So this is the last big tick mark that the volume, that the volume passes. So we know 0.3. Now, what about the next little tick marks? How many do we know for sure? Here's 5. Here's 6. I'd say it's past 6. I would say, like, I feel like I would say 7, and I feel like it's right on the line. So that'd be a 0. But what else might you have said? 0.36, 9, right? Because it does have a bit of a dome, right? Okay, yes.
How much leeway do we have?
It's an estimation. It's an estimation. So as long as you're close, it's fine.
Okay.
It'll be multiple choice. The whole exam is multiple choice. That makes you feel better. But so it's going to vary. The end is going to vary. Yes, sir.
Why would you consider 6 then looking at the film? Because as far as I was always told, you don't look on the actual look right.
At the tick mark. Yes, you look right. That's why I say 0.370. It's exactly right. Look at where that black, I got to erase all my marks, right? You always look at exactly where that black is touching the tick mark, because that's how they're calibrated. The good ones, that's how they're calibrated, right? Okay, good. All right, awesome. That's practical application, woohoo, right? All right, let's see. Okay, now this one, we got to go back to multiple choice. All right, this one, identify the number of significant figures in the thermometer reading, and the thermometer, if you can't read it, is reading 101.8 degrees F. That's what it reads. One minute. I don't think you're going to need 1 minute for this one. Okay, you got about 10 seconds. Yes, ma'am.
Nothing's just like not working.
Close it, swipe it up, get rid of it, and get back into it. Okay. So now, turn and talk to your friends. I'll give you 30 seconds on this one. 30 seconds. You can do this in 30 seconds. Check back in and answer. God, that was a short discussion. I have a feeling that y'all are going to do very well on this one. Okay, 10 seconds. Okay, so what did we say? All right, D is correct. D is correct. And we went from 88 to 89%. All right, so what's the difference between this sort of measuring device and the syringe? Is there anything to estimate here? No, all you can do is report what you see, right? So is the decimal present or absent? Present. Which way are we coming in from? First non-zero number and count the rest. How many significant figures? 4. Yeah. Okay. So no estimation on digital things. It's easy, right? You just record that. Okay. All right. So let's switch over to our in-class problems. If I could do the right thing on here.
Can we like power these off now?
Yeah, you can power those off. Sometimes I'll have some throughout the class. Like sometimes we'll do a few in the middle of class, but not today. Okay, the last thing we did, we were talking about temperature, right? So here we did 1.42, right? That was our last one. So we're on 1.44. So y'all know that you don't have to be copying down these problems, right? You know where to go and get them? In the chapter 1, it says lecture slides, in-class problems, pre-recorded video lecture. So then, if I can make this bigger. Right here, here's the lecture slides, then here are the in-class problems, and it takes you to the PDF, and you can download that. Okay, and I want to see anybody having to copy questions. And y'all know where I get these questions, right? From the book. They're the book's questions, right? Good. Okay, so when we talk about chemistry, it's also very related to physics, right? When we talk about energy. We're going to talk about energy off and on throughout the whole semester. So there are different kinds of energy, right? In physics, what are the two main types of energy? Kinetic and potential. Kinetic, what do you think of? You're moving, right? Something's happening. What is potential? It's held still, right? But maybe it's up really high and it's about to fall. So it has a lot of potential energy, right? Okay. So in chemistry, sometimes we talk about that, but think about what's the kind of energy that's important for life? What do you have to do every day so you have energy? You have to eat, right? So that's chemical energy. There's chemical energy that's stored inside of the hamburger you had for lunch, right? So you can think of chemical energy kind of as potential energy, right? If you eat that hamburger, now you have the potential to use the energy that was in the chemical compounds that were inside of that hamburger, right? So that's why we talk about energy in terms of science. I feel like sometimes you read this and you're like, why am I doing physics? You know, but it really is kind of important. So think about the different types of energy that are present when we have this little kid and they climb to the top of a slide. They stand at the top and they slide down. So here's our climb. This is at the top and you're going to slide down. So tell me about this climb. What kind of energy do we have present during the climb? Kinetic. But do you have the same amount of energy if the kid is on the bottom rung or if the kid is on the top rung? In the back, we need to have our mask on the whole time. So do you have the same amount of, does that little kid have the same amount of energy at the bottom as at the top? No. So what's happening when the kid is climbing? So our kinetic energy is being exchanged into potential. Kinetic converted to potential. I didn't give myself enough room, right? Okay, what happens when they get to the top? It's all potential. Like the kid is standing still, they're on the precipice, right? So this is all potential. What happens when they slide down? Now, depending on where they are in the slide, right, tells you how much kinetic energy they have. So if they're at the very top of the slide, they have way more potential than kinetic, versus at the bottom, they only have a little bit of potential and a lot of kinetic, right? So it's the opposite. So we have potential converted to kinetic. And it's just fun to see a kid slide down the slide, just is. All right, so you had that nice hamburger for lunch, right? Now you have the energy to go for a walk, right? Because you ate something, now you're able to use that energy to do things, for example, movement. So we know that different things require different amounts of energy. That's what exercise and diet is based on, right? So when you're looking at food on the shelf and you look at the nutritional content, how do they tell you about energy? They tell you about calories, but what they don't say is that there are two different kinds of calories. So terrible, right? There are nutritional calories. So a nutritional, we'll put nutritional in parentheses, CAL, calorie. Then there is a chemistry calorie. The nutritional calorie is the big C. The chemistry calorie is the little c. So in chemistry, we relate calories to energy, to actual units of energy. So we know that in chemistry, one chemistry calorie is the same thing as 4.184 joules of energy. But how does that relate to a nutritional calorie?
For every one nutritional calorie, it's 1,000.
Chemical calories. That's right. That's right. Okay. So if we're saying that we have a wok that burns 225, what kind of calories is that? Nutritional, because it's a big C. So I have a moderate wok that burns 225 nutritional calories per hour. Calculate the number of joules burned by this activity. What kind of a problem is this? It's a conversion. It's a dimensional analysis, right? We know how to do that. We can do that. So always look at what you're going to start with and always look for your goal. What's my goal to get to? Joules. Here's my goal. It's good to point that out. And it's good to write out your equivalences that you're going to use in the problem. Well, guess what? We already did that, right? So now we just have to decide what value are we going to start with. It's only one given, right? 225 nutritional calories. I'll just write a big C. Is that it? 225 calories per hour. And I want to convert to joules. Okay, so what am I going to do? Fence posts, right? What goes on the bottom? I want big C calories on the bottom so that that cancels. Can I go from big C calories to joules? Nope, I really can't. I wish I could, but I can't. So what am I going to have to do? Go to the chemistry calories. So how many chemistry calories and how many nutritional? There are 1,000 chemistry calories in one nutritional calorie. Am I done? No, I want to be in joules. So my calories have to cancel. And I know I have 4.184 joules in one chemistry calorie. So let's make sure my unit's canceled. I'm left with joules per hour, and that's good. So what do you get? $900, what? 9,400. Say it again. 941,000. Yes? Okay, is that answer correct? Well, you could say joules per hour. You could say joules per hour, or you could just say joules because it says burned by this activity and it was in hours. So you could leave it as joules or you could leave it in joules per hour. Either way would be fine with me. What am I not thinking about here? Sig figs. Your final answer cannot be any more significant than your least significant initial value. Look at all of your numbers in the problem. How many significant figures? 3. 225 is 3 significant figures. So how many significant figures can my answer be? 3. So I have to round that to what? Yes? You could do either way. You could do either way. Okay. So the next one, we're going to talk about specific heat. So when we talk about specific heat, you don't have to memorize values of specific heat. I'm not really worried about you guys in specific heat. But if you were to go in your textbook and you were to go look up the table, if I were going to ask you this, I would give you the table. I would look up in water. I don't remember what page it is, but I looked it up, and so we're going to look up specific heat for water, and we're going to look up specific heat for salt, because we want to compare the specific heat of pure water versus the specific heat of salt water. So if you look up specific heat for water, that's 1, right? That's 1 calorie per gram degrees Celsius. Specific heat of salt is 0.21 calories per gram degrees Celsius. So it's how much energy is required to raise 1 gram of a substance by 1 degree Celsius. So which one do you think has a higher specific heat, water or salt water? Which one? Water or salt water? Salt water. Why? So when you think about it, right? Have you ever added salt to your pasta while you're boiling your pasta, right? We say we do it to make it, what do we say? It's gonna boil faster. That's wrong. It's wrong. But it does change things. So when you have water, right, and you put stuff into water, whether that's a salt or sugar, whatever, you put stuff into it, it is going to change the properties of that substance. So basically all these water molecules, when you heat them up, when they get to a particular speed, they go faster and faster and faster. What's going to happen? Eventually, right, they escape the liquid and they become gas. So your water is boiling, right? Right? That's boiling. Okay. So you do the same thing, but you add salt. What's going to happen to those water particles are actually going to hit the salt particles. And so instead of escaping, they're going to bounce back into the liquid. So it's going to be more difficult to boil that pot of water, right? So what happens when we add solids to a liquid is we change the boiling point. So normally water boils at what temperature? 100 degrees Celsius. So what happens if I add salt to my water? Maybe now it boils at 101 degrees Celsius. So you're not actually boiling faster. It's actually taking longer to boil, but you're boiling at a higher temperature. Same thing's true with a radiator fluid, right? How do you keep your car cool? We put liquid water inside of the radiator tank, right? Because water has a really high specific heat capacity. It can take a lot of heat and it'll keep your engine from overheating. But when you buy it at the store, is it just pure water? No, usually it's colored, right? So that you know that they've added something to it. It's artificially colored. That's why they color it. So you know that they've added stuff to it. And it prevents things from boiling as quickly, right? It has to get to a higher temperature. Your car has to get to a higher temperature before that radiator fluid will evaporate. Prevents your car from overheating. Cool, right? You always wanted to know that. I know you always wanted to know that. You were desperate to know that. All right, back to regular chemistry. All right, indicative each of the following describes a solid, a liquid, or a gas. The state of matter that has a definite volume but takes the shape of its container. What are we? Liquid. These are easy. The particles in this state of matter are so far apart they do not interact with one another. So easy, right? Need some easy ones. Okay, now measuring matter. This is pretty important. When we're measuring matter, there are two different terms that we use to describe how we measure matter. What are they? Accuracy and precision. How do we define those two terms?
Accuracy is like getting, like reaching the goal, but precision is like you might not reach the goal, but it's like in the same area.
That's right. That's exactly right. Okay, so accuracy is how close you are to an actual value. So in this question, consider the following measurements determined for a known volume of 10 milliliters. Your known volume, that's your actual value, right? So this is an example of your actual value. Okay, what is precision? How close those measurements are to one another. They might not all be 10 milliliters, but they might all be really close together. So you might get 8.1, 8.2, and 7.9, right? That's really close together. But was it at the actual value? No. So precision is how close, I don't know, oh, when you click the button, how close a series of measurements are to one another. Right? Okay, which set of measurements is more precise? We're going to measure the same volume of 10 milliliters with a graduated cylinder, and we're going to measure it with a beaker. Before we even answer these questions, which one do you want to measure with? Just don't look at the numbers. Graduated cylinder or beaker if we're measuring volume. Graduated cylinder. Graduated cylinder has way more of those tick marks, right? So the more tick marks you have, the better you can estimate the volume, right? It's all about the number of tick marks. Okay, so let's look at these two sets of measurements. If I took an average, what would I get for each of these? You have your calculators? What do you get for the graduated cylinder? What do you get for the beaker? 9.67. What? Okay, close enough. Okay. So the average can give us an idea, but sometimes you can get two averages that are exactly the same, but the precision and accuracy are still different. So how would we look at accuracy? Oh, no, the first one, I'm sorry, is precision. Which one of these two is more precise? So which one have our closest series of measurements to one another? The graduated cylinder. How far apart are is the biggest distance? Well, 10 to 9.5 is 0.5. And I have a 1, right? What's our biggest difference? 9.5 to 10.5, right? That's 1 milliliter difference. Okay, what's our biggest difference with the beaker? 4 milliliter difference. That's big, right? That's really big. We don't like that, right? We want all of our measurements to be very close to one another, so very precise. Okay, which set of measurements is more accurate? Look at each individual measurement. Which measuring device do we get as close to 10 as possible every single time? Again, the graduated cylinder, right? 10 is exactly 10. Here you're only 0.5 away. Here you're only 0.5 away. right? 12 milliliters, how far away are you from 10? 2 milliliters, that's horrible. How far away? 2, how far away? 1. So do you see where we're getting the numbers for accuracy and precision? Okay, so which measuring device is more accurate? Graduated cylinder. Which one would you want to use? Graduated cylinder. Okay. Or a syringe. A syringe is usually really good too. All right, now we are going to do some of, I think, what are the most applicable problems, possibly even for the whole semester. So if you're going to be a nurse, right, you have to be able to do what are called dosage calculations. So these are a bunch of different kinds of dosage calculations that we're going to do today. So here we have a mother who's supposed to give her child 10 cc's of medicine every 6 hours, but she lost the syringe provided with the liquid medicine. Trust me, it happens all the time. She calls your clinic for help. How much medicine in teaspoons can you instruct her to give the child per dose and per day? So just think, right? She needs to, number one, know how much to give her kid when she doesn't have a syringe to measure it, right? And we don't normally operate in cc's, right? Not in your kitchen. Okay, and then what if, I don't know, the kid knocked over the medicine bottle, right? They got mad, they didn't want to take their medicine, they flung their arm, they knocked it over. Well, she wants to know if she has enough to get her through the day before the pharmacy opens tomorrow, right? So these are really important questions. So what kind of a problem is this? It's a conversion. It's a dimensional analysis. It's fence posts, right? So all we have to do is change units. So what equivalent relationships do you see inside of the problem? So the kid's getting 10 cc's per 6 hours. Okay, that's one thing. What's our goal? I want two things. I'm going to come down here. I want two things. I want teaspoons per dose. And what else do I want? Teaspoons per day. Okay, those are my two goals. So start out with what you know. She needs to get 10 cc's per what? 6 hours. What do we call that time period? If I tell you to give this person medicine every 6 hours you're giving them a dose, right? So it's 10 cc's per dose. Okay, now she lost her syringe. So you need to know what's the conversion factor between cc's and teaspoons. Anybody know? Yeah, but it's hard to work. Sometimes it's hard to work with halves. Can we do it with all whole numbers? 1 cc is what? Yeah, but let's go straight to teaspoons. 5 cc's in 1 teaspoon. I think that's on your conversion. Is it on your best friend? I think it's on your best friend. Pretty sure it's on your best friend. Is it there? Okay. All right. So where do cc's go? At the bottom. So I'm going to put 5 cc's and then teaspoons. P-O-O-N-S. Gosh, I can't spell. Teaspoons. Okay. So what cancels? cc's, and now I get what? Teaspoons per dose. So how many teaspoons per dose? Ten divided by 5 is 2. So 2 teaspoons per dose. So this is my answer to number 1, right? But am I done? No. Okay, so what do I need to do? We need to make sure she has enough for the rest of the day because the pharmacy doesn't open, right? Okay, so I want to convert Now, what am I trying to get rid of? Dose. I'm trying to get rid of dose. What goes on the bottom? I heard somebody say it. Hours. How many hours in a dose? 6, because she's getting 10 cc's per 6 hours. That means 1 dose occurs every 6 hours. Oh my gosh. I'd like to blame the pen most of the time, but it's usually me. Okay, so in 6 hours, she gets 1 dose. So my doses cancel. Am I done? That's teaspoons per hour. Is that what I want? No, I want teaspoons per day. So I want my hours to cancel. Hours go on top. Days goes on the bottom. How many hours per day? 24 hours in 1 day. So what do you get? Our hours cancel. You get 8. 8 teaspoons in 1 day. And that was our answer to the second one. Yeah? Okay, so now she knows if she can make it through the day. All right.
So you do 2 times 24 divided by 6.
So you would do, let me scroll down. I would do 2 times 24, hit enter, then divided by 6.
And then 8.
Yeah? Yeah, be careful when you're putting this stuff into your calculator. Either use parentheses or get everything on top and everything on bottom and then divide the top by the bottom. Either way works, but order of operations is important. Okay, now, yes, ma'am.
So you're giving on the exam that you're giving us a copy of that thing, or do we get?
No, I'm providing it to you. I am providing it to you. Okay, now this gets a little more complicated, but trust me, you'll have to do this. So you have a 38-pound child that is prescribed a medication for chickenpox in the amount of 80 milligrams per kilograms of body weight per day to be divided into 4 doses. That's a lot of information in one sentence, right? Okay, it's all right though. Each tablet contains 700 milligrams of the medicine. How many tablets should be given per day, per dose? So what's our goal? Tablets per day, tablets per dose. Okay, now, one thing I want you to also recognize, the weight of the child is in what? Pounds. The medication is in what? Kilograms of body weight. So I automatically know I'm going to have to convert that, right? Because listen, children are small. So if you give them too much medication, you could really injure them, right? So calculating doses is super important. And the smaller the mass of the individual is, the more critical that calculation is. Okay, so you have to be very careful. So I know that I'm going to have to do a conversion where I convert from pounds to kilograms, right? So what am I starting out knowing? That the child is 38 pounds, right? What else do I know? We have 80 milligrams of medicine per kilogram of body weight per day, right? And we get that in 4 doses. We're going to divide that into 4 doses. We're going to say in 4 doses, right? I really should have left myself way more room for this. Okay, I'm going to take it down here. We're going to put stuff up here and I'm going to do it down here and then I'll erase this, okay? All right, so what I want to start out with is I'm going to start out with this 80 over here, okay? So I know the medication that I'm giving my patient has to be 80 milligrams per kilogram of body weight per day. We just put a lot of lines in there, didn't we? Okay, so let's do the top. Let's look at how much we're actually going to give the child, and then we'll do that per amount of time. So I have to convert from kilograms to what? To pounds. Look on your favorite friend, your best friend. What's my conversion? 2.2 pounds per kilogram, which you could say pounds is equal to 1 kilogram. I like writing those equivalent relationships and then putting them in. So that's 2.2 pounds in 1 kilogram. So my kilograms cancel, right? Now I know how many milligrams per pound to give the child, right? So how much does the child weigh? 38 pounds. So now my pounds cancel, and I'm left with on the top, what? All right, what am I left with for units on the top? Milligrams. So that's what? 80 times 38, hit enter, then divide by 2.2. What do you get? .8. What's my unit? Milligrams. And then what goes on the bottom? Per day. Does that answer any of my questions? My first one says, how many tablets should be given per day? Nope, I'm not there yet. It's okay. So now I need to convert from milligrams per day to tablets per day. So do I have an equivalent relationship that will allow me to do that? Yeah, each tablet contains 700 milligrams of medicine. So now I'm going to put that into my dimensional analysis. And what am I going to do? Milligrams on the bottom, tablet on top. Then one tablet, there's 700 milligrams. So take 1,381.8, divide it by 700. What do you get? 1.972 for so on and so on tablets. ABLE 974 per day. So are you going to measure out 1.974 tablets? No. Look at your sig figs in your problem. How many sig figs? How many? 1. So what should we convert that to? 2 tablets. Okay, so we answered the first one, right? How many tablets should be given per day? We answered that. Now, how many per dose? Do we have a conversion factor that would allow us to talk about dose? So we're given some amount of medicine per day to be divided into 4 doses. So what does that tell me? In one day, I have 4 doses, right? So days we want to cancel out. And then we're going to put dose on the bottom. So in one day, there are 4 doses. So how much do you get? Because your days cancel, so you're in tablets per dose. 0.5 tablets per dose. Can you cut a tablet in half? Absolutely. We do that for kids a lot. Okay. Yes.
When you do the like the 80 milligrams,
Mhm.
milligrams per day, why do you like? How do you know when to round to that one?
Well, because we're given, it's the final question, how many tablets should be given per day, right? When you get to the end, then you're rounding.
Yeah, but like when you have the step before that to get milligrams per day,
1,381.8, doesn't matter.
it doesn't matter.
It doesn't matter. Don't round until the end. I mean, it was one significant figure. So long as you have more digits past that, you're good. And if you keep it all in the calculator too, then you never have to worry about it. Yes, ma'am.
Where did the 2 sig figs come from?
The 1 sig fig,
The 2. Or we did a tablet per day.
when you did tablets per day, how many significant figures are in this number? It's 1 sig fig, right? And so if I look here, 10, how many sig figs are in here? 1. 10 days, how many sig figs? 1. 50 milligrams, how many sig figs? 1. So your least significant value determines the number of significant figures in your answer. Question?
I thought we were doing most of that.
Oh, I'm on the wrong. Oh, sorry.
It would be-
Sorry, you're right. So I'm looking up here. 80 is 1. Oh, 38. 38 is 2. 38 is 2. So you could say 1.97 still rounds to 2.0. Right? And then what is your 0.5 actually in your calculator? 4.9 what? 3.5, but really practically thinking, what are you gonna do? You're gonna cut it in half. You're gonna cut it in half. But yeah, it should be 2 sig figs. No, I'm sorry, it should be 1 sig fig. Listen to me, it should be 1 sig fig. Your lowest sig fig in the problem tells you the sig figs in your answer. And so the lowest. So 80 and 700, these are both 1 sig fig. So your answer should be 1 sig fig. Okay. So now I got to erase this stuff. Y'all got it? Y'all wrote it down? Okay. That's what happens when I'm writing all over the place. I need to redo this with more space. I feel like y'all have enough space, but this marker writes so thick. Okay. So we got another kid who's got some more medicine they have to take. Child must take 10 milliliters of an antibiotic 2 times a day for 10 days. Our solution is provided as a 50 milligram per milliliter suspension. How many milligrams will the child have taken when the course of medication is over? So what's our goal? We're trying to get milligrams that this kid has total taken. Why is that important? Right, because usually if you think about a lot of different medications, especially antibiotics, they can have toxic effects if you give it for too long, right? So you really have to think about how much total you are putting into a lot of times a child's body, especially. So that's actually a really important piece of information. They don't necessarily tell you that why here, but it really is important. Okay, so they're going to take 10 milliliters, right, by mouth, 2 times a day. So they're going to take 10 milliliters 2 times per day for 10 days. That's our numbers, right? And our solution is provided at a 50 milligrams in 1 milliliter suspension. Right? What are we going to start with? Doesn't really matter what you start with. Pick something. Say 10 milliliters. We're going to give this kid 10 milliliters. How many times are we going to give this kid 10 milliliters? 2x per day. Now we're in milliliters per day. Okay. What else are we doing? We're going to give it to them for 10 days. What happens to my days? They cancel out. Okay. What else do I know? Going to give the kid 50 milligrams per 1 milliliter. What happens to my milliliters? They cancel. So what am I left with? I'm left in milligrams. Okay, so do the math. 10 times 2 times 10 times 50. That? 10,000? 10,000. I think you missed a 10. 10,000 milligrams over the whole period. Right? Usually you don't want to give so much of a medicine.
That over 10 days, basically.
Correct. Over a 10-day period, the child has ingested 10,000 milligrams of medicine. That ends up being quite a lot. Okay, I'm going to erase this stuff. Look at me, I missed one on the recording too, didn't I? I'm supposed to do all the odd numbers. I missed one. Okay. A patient gets, okay, this is another way to give a patient medicine is through an IV, right? So this patient needs to get 2 liters of fluid over 18 hours through an IV. Okay, so if you give a patient too much through an IV too fast, what are you going to do? You're going to blow their vein. It's going to be bad. So you have to make sure that you're putting the medicine through their IV at a slow enough rate that you're not harming them, but fast enough that they're getting the medicine that they need, right? Or the fluids that they need. Okay, so they're getting 2 liters of fluid over 18 hours. The drop factor is 20, and this is the abbreviation for drops. So 20 GTT is 20 drops, right, per milliliter. So calculate the drip rate in drops per minute. So that's drops per minute is GTT per minute. So when you see GTT, think drops. Okay, so what do we start with? Well, what's our goal? We really should think about goal. What's our goal? It's GTT per minute. I always like to know what my goal is before I start. So what do you want to start with? 2 liters in 18 hours. Okay. What do we want to get rid of? Okay, let's do hours first, because we really want to get to what? Minutes. Okay, so I'm going to put hours on top. Can I put minutes on the bottom? Sure. In 1 hour, there are how many minutes? 60. Okay, so now I've got minutes. That's great, but I'm in liters per minute. Is that what I want? No. Okay. What do I do? My liters is on the top, so I now need liters on the bottom. Okay, now what? We know we have 1,000 milliliters in 1 liter, right? That's from our best friend. Now, what do we know? In 1 milliliter, we have 20 GTT. What unit am I in now? Drops per minute. That's what I wanted. So what do you get? What do you get? Okay. Sig figs. How many sig figs should my final answer be? 1. 1. So what should it be? 40. Really? Honestly, this should be a decimal behind it, so that you would then have 2 significant figures. Like if you were really doing this for real life, but it's okay, right? Okay, and then that's what you would set the machine at. You would tell the machine how many drops per minute to give the patient, right? Okay, how long would it take in hours to administer exactly 500 milliliters of fluid through an IV with a drop factor of 30 GTT per milliliter if the drip rate is 60 GTT per minute? So basically what this question is asking, you're going to set up an IV for somebody, right? You're going to stay there and make sure it's going. Then you're going to come back and check on them. How long before you need to come and check on this patient? When should their IV be done? That's the question, right? So what's my goal? Hours. Hours is my goal. So what are we starting with? How much do I want to give my patient? 500 milliliters. That's what I want to give my patient. Do I have to have something on the bottom? No. So I know I want to get rid of milliliters. I need to get to hours. So milliliters is going to be on the bottom. What goes on the top? Right? So I know I have 30 GTT per 1 milliliter. So my milliliters canceled. Now what? GTT is going to go on the bottom. What am I going to put on the top? Minutes, because this is what I have here. So I'm going to say I have 60 GTT in 1 minute. Am I done? No, my GTT cancels, so I'm in minutes, but what's my goal? Hours. So minutes on the bottom, hours on top, 60 minutes in 1 hour. My minutes cancel. I'm left in units of hours. So do 50 times 30, hit enter. Divided by 60, hit enter. Divide by 60, hit enter. If you're doing it on the $10 calculator, it's probably the easiest way to do it. You need to practice this on your calculator while you're in class, using the calculator you'll be using on the exam. Yes, ma'am. What'd you get? 4 hours. So what did you get in your calculator?
4.16.
Right? But how many significant figures do we have? 1, so that rounds to 4. Very good. Very good. Cool. So this is like one of the most applicable things, I think. Oh, I'm telling you that you will have problems like this on the exam. Like really similar to the ones we just did. Yes, sir. Look on the calendar and you'll find all of our exam dates.
So even if questions like this are not.
Yep. Yep. Okay. So remember how we were doing, oh, I'm sorry, yes. Yes, exams are on paper unless, knock on wood, you know, the university goes online. Please don't. That's why we're all wearing our masks over our nose and mouth at all times, right? Hopefully they will be here in person. That is the plan. Okay. All right. So remember how we were doing the conversion from, another question? I'm sorry.
Yeah, that was a quick question.
Sure.
Do we have to have a Scantron?
No. I'm going to give you, I use something different, but it's like a Scantron. So I will, the only thing you need to show up to on exam day is a writing utensil, and I highly recommend a pencil. And your calculator. That's it. I give you everything else. I give you the exam resources, I give you the exam, and I give you the answer sheet. Yeah, it's a good question. Okay, a medium-sized carrot weighs 61 grams. Oh, it's a carrot, like my joke. It weighs 61 grams and contains 6 grams of carbohydrate. What percent of that carrot is actually carbohydrate? So we did this, we did problems like this, right? Earlier in the chapter. So how do we set that up? What percent of the carrot, so X percent of the carrot, what is the carrot? 61 grams of carrot is, what do we say is? Is the same thing as equals the carbohydrate. So the carbohydrate, we said 6 grams of carbs. So what is X? What is X? Throw it out there. Somebody be brave. What's that? It's a percent, so it's probably going to be less than 100. 9 point what? 9.8%. sig figs? 10%. Because our least number of significant figures is 6 grams. So 1 sig fig, round it to 10. Cool? Lots of math. Y'all just in love with math now, right? Okay, that's it. That's it for this chapter. Woohoo! We're only about a day behind. Okay. We're gonna catch up. All right, so go to chapter 2. Go to chapter 2. We finally get to start talking about atoms. Isn't it exciting? Y'all are like, no, but okay. So we're gonna, when we first start talking about chemistry, right? We'll talk about kind of the whole atom, and then we're gonna start really in the nucleus. And so we're gonna talk about how the nucleus is related to radioactivity. And then in the next chapters, we'll go out to the electrons and we'll figure out what the electrons do, and then we'll just build and build and build. Okay, so I didn't do these so we could do these in class together. What subatomic particles are located in the atom? List them for me. Proton, what's the abbreviation? P plus, what else? Neutron. What's the abbreviation? And? Which is? E minus, E negative, yep. Okay. How does the mass of a proton compare to the mass of a neutron? How does it compare? What should go right here? An equal. They're about equal. They're very close. So we'll say approximately equal, right? How does the mass of an electron compare to the mass of a proton? It's much smaller, right? So we're gonna say, we're gonna give our little alligator. Remember the alligator eats the bigger number? Remember that? How do you ever forget that, right? Louisiana's got to be the alligator. But by how much? Yeah, an electron is like 2,000 times smaller in mass. Like by a lot, right? Not just a little, a lot. What units do we use to describe mass? They're called the atomic mass units. So AMUs. So 1 proton weighs about 1 AMU, right? So 1 AMU. Ooh. And what about a neutron? A neutron weighs about 1 AMU. So our electrons, we just kind of say they're negligible mass. They do have mass, but we just kind of say they're negligible. All right, so when we look at the periodic table, whether you're looking on the wall or you're looking on your best friend, right? If we pick carbon, what number is at the top? Number 6. What does the number 6 refer to? The atomic number. And the atomic number is what? Number of protons. What else? It's the number of electrons in an atom. And by definition, an atom must be what? Neutral. If it is not neutral, what do we call it? No. An ion. Ions are charged atoms. That's just kind of a side note, right? Ions are charged atoms. So if it says atoms, you must assume that it is neutral. If it is not neutral, we will call it an ion, okay? All right, mass number. You see the mass number up there? Anybody? No, there's another number. There's another number on there. That's the atomic mass. The atomic mass is not the same thing as the mass number. If something is a number, it's a counting number. So it's our number of protons plus our number of neutrons. The mass, the atomic mass that you see on the periodic table, do you see how those are decimals? Those have crazy decimals, right? That's not accounting. You can't have 0.994 or what are we looking at, carbon, 0.011 of a carbon atom. That's a mass, not a mass number. So be careful with that, okay? So what can we determine if we have the mass number, which is the protons plus the neutrons minus the atomic number? What can we get? Number of neutrons. Yeah. Okay. So now let's use our handy dandy periodic table. Provide the name and atomic symbol of the element that has the following atomic number. 79. Go look on your periodic table. What is 79? Give me the symbol first. AU. What is AU? Gold. And if you're ever not sure, if you turn to the second page of your best friend, it has all the symbols and all the names together. Okay, so you can always go and find it. 19 is K, and K is potassium. 82, PB. What is PB? Lead. 33. It's the weird ones, right? AS. What is AS? Arsenic. Arsenic. What is 11? Na. What is Na? Sodium. All right. So now, when we look at mass numbers, there are two different places where we find a mass number. Where do we find a mass number? So if I said carbon 12, the 12 is the mass number. But if I do the big symbol, where's the mass number? Top or bottom? Top, what will go on the bottom? The atomic number, which is number of protons, which is 6. So the mass number is in one of two places. So what is the mass number for a fluorine atom that contains 10 neutrons? So look on the periodic table. How many protons are in fluorine? 9. So what is my mass number? 19. Okay, it's just a counting number. It should always be a whole number. All right. Determine the number of protons, neutrons, and electrons in the following atoms. So we want protons, neutrons, and electrons. Okay. A helium atom that has a mass number of 4. Helium, how do I know the number of protons? I'll go look on the periodic table. What do I see? How many? 2. Now, how do I know number of neutrons? I take my mass number minus my protons. What do I get? 2. Electrons. Because why? It says atom, and they're the same in a neutral atom. Okay, a carbon that has a mass number of 14. How many protons? Every carbon must have 6 protons. That's what's on the periodic table. If it's carbon, it has 6 protons, always and forever. Number of neutrons, because 14 minus 6 is 8. Number of electrons. Now, I don't agree with this. I think they should have said a carbon atom that has a mass number of 14. Now, what do you know it has to be? 6. I promise I'll be clear about that on the exam. Okay. So we will stop there. I know we're a little bit behind, but we'll catch up. If you are going ahead and doing the homework, if you go on to the next one, I want to show you this real quick. You see how there are those numbers up above and numbers below? You have to make sure they're stacked one on top of the other. There are buttons for that in the homework, right? If they're off to the side, one's off to the side, it's going to mark it wrong, even if the numbers are right. So they have to be perfectly stacked, so superscripts and subscripts.
And we can make sure there's no, like line too.
Yeah, there's no line. There's a thing to insert. They call them, I thought I wrote it down, they call them stacked superscripts and subscripts. And there's a button for it. But like when you do it, there are like little video tutorials that'll show you how to do it. Yep. Okay, let me ask, I minimized my chat. I'm so sorry. Okay, anybody on Zoom need anything before I end the Zoom? I'm sorry, I hid the chat. I gotta do better. Okay, no questions. All right. I'm gonna end the meeting.